Oh, you're now recording the actual scene, so it should just be audio normal, which kind of funny. That means that I'm not doing wrong. That means VCam is acting up. VCam must not act up here. Okay, guys. If this is recording, if it's not, I have to do it again. Okay. It is recording. It is VCam that's acting up. Hopefully, it is recording. Actually, VCam. Yes, original remove my face, keep it original. Yes, should be seeing me. It's still, okay, but it's working as intended. Okay, let me just do it. So, guys, this video here is about this video, no, path forwarding. But it's more about geometrical alignment. But we're gonna watch this video first. I'm gonna give you what we're gonna talk about. I'm gonna watch here. If you go to my Substack here, look, OBINexus Computing. I can't even log into my account. Namdi Balab, you can go to at OBINamdi on Substack, and go to my YouTube channel there. But I'm trying to get this video uploaded to my my other YouTube channel, but we have to watch it to see what I mean. Because it's very important we get this right. When we ascend the planes, we have the unit model. We are actually working on the fraction unit and unit model. So which is just the standard unit model for the universe. Again, which is like we have a tenth unit. We share units. We don't share units. Basically, our inverse is their inverse. So our zero is their our nothing. Our decimal place unit is there has their own conjugate. So our dot unit dot zero is flipped to. So our zero is their dot zero. Our tens is their scalar, like a one to them. Our hundred, so is there 100 is basically inverse based on the cost system. It's very important to understand this before we continue for space-time auxiliary computation of our sparse structures with lattice integrity, which I just forgot the name because I have to read the name, review the name to it. But what I'm gonna show you guys is this video because this video is very important you watch it with me, so I can show you guys why this matters. Okay, basically, this video I'm showing is my particular video. It's 4 minutes long.
Hello everyone, I'm going to show you guys the proper method to draw a square with 3 lines. Okay, I'm going to show you the wrong ways and the right ways to do it, okay? And how I've done it, okay? So here I go. The wrong ways are this. So this is the wrong way to do it. Four sides. No. Three lines, 4 sides. No. 3 lines, 1 line, even worse. No. No. Okay, we'll go here. No. Okay. Follow, like, and share and subscribe if you like the video. I'm not gonna show you how I figured it out and the right way to do it. Okay, let's start with the right way. So you're gonna take this paper and fold it to make a right angle. A right angle like this. Or a right angle like that. And then you're gonna use one line to one line. Green. And you're gonna go, that's one line, and you don't pick up your pen. I picked up my pen, but that's one line. This counts as one, and use the edges. You go here, 2, 2, and 3. This is one line, 2 line and 3 line, and this is your square. Yes. Now, the way I figured this out is simple. Was simple. You take, so this is how I figured it out. You take say you draw in a circle. I realize the circle. So you have circle here. There's no, this is circle. Just a different method. This is how I figured it out.
Guys, don't worry about that, guys. Okay, guys, basically, the video is there complete. But what you gotta understand is, it's not really theoretical. It's just practical. Once you can see, the folding of this paper I was folding was literally bending halfway to the center of the system. But the same center is the opposite way. So you don't like fold it in half. You don't take the units. You take dimension less of the units, because this is a square paper. So let me just make it a square paper. So if I fold it in half first, oh wait, sorry. If I make it a square, if I fold it in half, it's what? It's a square. So basically, if I fold it twice, it's still a longitudinal more. But if I fold it twice, it's what? A square. A square. Square. Follow me if any says. Me, it's a square now. Oh wait, it's not a square. No, it's still longitudinal. No. Okay. Anyway, don't worry about this thing. It's not a square. So if I have the paper, I have to half it. Anyway, so I can look, guys. Don't worry about this. Let me just get to the point. My point here is, the paper is long. It's a plane. It's an infinite plane of existence. Now the fabric spaceman is this. This is the fabric of the X coordinate system. Their negative, their unit of 100 is my other one flipped, inverted. So if their unit of 100, 100 is my 100. Etc. etc. So that is basically its conjugate. Is a conjugate inverse. Basically, conjugate inverse just means 100. I have 100 units here, but I have to 100 units is 100 units. So basically 100 units. My 100 inverse of my 100 units. My epsilon of my 100 units is just minus 100. Minus 100. So that's my inverse 100. But the operator still remains. The operator is still there. The operator is still. So my 100 operator, my negative operator is my 100. So basically, I can store 100 kilo. Let's say I'm storing. Let me start with this. I've got it here. So see my paper here. I fold this paper. I fold it 6 times. But in my dimension, I can only fold it 7 times. But someone in the dimension can fold this paper. Higher dimension is 12. 12. So because of the half rule. Which I'll explain now. But you know, my 100, my 100 is there. My 100 is there 100. Like you know, units model. So you get a units model. You get a unit model. You get a 10 units. 10. 0.1. Then the tenth. 0.01. Which is their tenth. And my 100. 100 is there 100. 0.01. Invariant. So if I'm storing something, I have to store it correctly and polarize it correctly, because this has to be stored in their way. It's just to become conjugate inverse. So if I'm trying to store 100, I have to make sure it's flipped. It's really, I'm storing 0.01, the polar inverse of it, or the conjugate inverse, or the conjugate pair inverse. And how I'll do this is this. So I'm going to just have to flip it. So I have to create some of chamber to isolate that information. So basically, if I'm sending a radio signal to